on in. We're going to talk about geometric series today. Have a seat. All right, great. So last time we developed a general formula for the sum of a finite geometric series, one that had an initial term a and had n terms and had a constant multiple of r. Let's just look at an example of how we can use that formula. So to remind you, the formula we had was that the sum of the geometric series with n terms was a times 1 minus r to the n over 1 minus r. And again, that was for the series a plus a times r plus a times r squared. And we ended with a times r to the n minus 1, where we had n terms. So now let's take an actual series and see if we can write down the sum. Let's take a series. Let's suppose the series starts out to be 3/4 minus 3/2 plus 3 minus, can you guess the next term? Well, the next term, notice that we have the multiple here is minus 2, right? We've multiplied this by minus 2, multiplied this by minus 2. So what do you think the next term is? Well, it's going to be minus 6, right? And then the next term in the series would be plus 12. And let's continue multiplying by minus 2 a few more times. So minus 24 plus 48 minus 96. Now, we could find the sum for this series simply by putting it in a calculator. But let's just get exercise using the formula for the geometric series sum that we found before. So the first term in this series, which we called a, is 3/4. The number of terms in the series is 1, 2, 3, 4, 5, 6, 7, 8. So n equals 8. And the constant ratio or constant multiples, as we observed, which we're calling r, is minus 2. So according to our geometric series formula, the sum of the first 8 terms of this series, called S8, should be equal to 3/4 times 1 minus negative 2 to the 8th power over 1 minus negative 2. And we could stop there, or we could simplify this if we wanted to. Let's just simplify it. So what's negative 2 to the 8th power? Anybody know? Do you know? What's 2 to the 8th power? Do you know? Well, we could figure it out. 2 to the 8th power is 2 to the 4th power is 16, right? That's 2 times 2 times 2 times 2. And so if we square that, we get, what's 16 squared? 256, right? So this is 1 plus 256. Actually, it's 1 minus 256, isn't it? Because the minus sign is still here. Over 1 plus 2 is 3. And we have to multiply that all by 3/4. We could cancel the 3's, and we end up with minus 255 over 4. Does it make sense that the answer would be negative? Well, if you look back at the series, you see that we're adding and subtracting numbers, which are getting bigger, and so we just happen to have subtracted the minus 96 here, which gives us a negative number. Okay, so that's one example of how we can use this formula for the sum of a finite geometric series.